All right, let's get right into it. We're going to talk about what is quite possibly the biggest leap forward for AI we're seeing today. This is all about moving past the simple chatbots we all know and into something, well, something much, much more powerful. We're talking about augmented large language models. You've totally had this happen, right? You're chatting with an AI, and it gives you this amazing, super articulate answer. But then you ask it about, I don't know, yesterday's news, or you try to get a specific number from one of your company's reports, and poof, it just goes blank. It's this weird feeling, isn't it? How can something feel so smart and so clueless at the exact same time? And look, let's be fair. What these standard models can do is incredible. I mean, they get what we're saying in plain English, they can spit out code, they can summarize a massive article in a blink, and they're pretty good at basic reasoning. This is the stuff that made everyone's jaw drop. But, and this is the big but, for all that power, these models have some really critical flaws. And we're not talking about small glitches here. These are the kinds of flaws that are absolute deal breakers when you want to use this tech for something serious. You know, things like finance or medicine or cybersecurity. Okay, so this really breaks it down. On one side, you've got your standard LLM. It's basically a brain in a box, right? Its knowledge has a cutoff date, so it's stuck in the past. And because it's totally isolated, it starts making stuff up, what we call hallucinating. It's just guessing. But then look at the other side, the augmented LLM. This thing is connected. It can pull in real-time info, so it's always up to date. It grounds its answers in actual facts that it can point you to. And it can use tools and APIs to interact with other systems. It's the difference between something that just talks and something that actually does things. And that brings us to the main event, the hero of our story, the augmented LLM. This is the whole architecture that takes AI from being a fascinating toy to a tool you can actually rely on for serious work. So what is it really? Well, at its heart, an augmented LLM is just a regular language model, but one that's been given a whole support crew. It's like you're giving the AI a library card to access new books, a calculator to do math, and a keychain with keys to all sorts of other software. It's these extra pieces that let it finally break out of its box. Probably the best way to get this is with an analogy from how computers work. I want you to think of the base LLM itself, the GPT-4, the Claude, as just the CPU, the processor. It's the core brain, for sure. But a brain on its own can't really do anything, can it? This chart just lays it out perfectly. The LLM is your CPU. That's where the thinking and reasoning happens. But for it to be useful, it needs more. It needs memory, which is your data, your external knowledge. It needs some kind of control flow to handle bigger jobs with multiple steps. And that's what we call chains. And finally, it needs peripherals, ways to interact with other software. And those are the tools. See? Once you bolt all those pieces together, you've gone from having just a lonely CPU to having a complete working operating system. All right, so if the LLM is the CPU, let's dig into that first piece of the puzzle, memory. We're talking about external data, and this is exactly how we start to fix one of the biggest headaches in AI today, those pesky hallucinations. The secret weapon here is a technique called RAG. RAG. It stands for Retrieval Augmented Generation. And honestly, the name says it all. Instead of just guessing based on its old baked-in knowledge, the system first retrieves. It goes and looks up fresh, relevant facts from somewhere else. Maybe that's your company's internal wiki or a database of news articles. Then, and only then, does it use those facts to generate its answer. And the process itself is actually pretty straightforward, but it's incredibly powerful. So, step 1, retrieve. The system goes and finds relevant info from a knowledge base. It's like doing a quick Google search before you open your mouth. Step 2, augment. It takes those facts it just found and literally stuffs them into your original prompt. So now the LLM has all this extra up-to-the-minute context. And finally, step 3, generate. The LLM creates the answer, but now it's not just pulling from its memory. It's using the fresh, factual info you just handed it. And the difference this makes is, well, it's huge. We're not just talking theory here. Real-world studies, especially in high-stakes areas like healthcare, show that a simple RAG setup can make the AI 8 to 15% more accurate. I mean, think about that. That can be the difference between a useful tip and a flat-out dangerous mistake. This is how you tackle hallucinations head-on. Okay, so we've given our AI memory using data and RAG. Now we need to give it control flow and peripherals, the pieces that let it actually do stuff. And that's where chains and tools enter the picture. This is what turns the AI from a know-it-all into a do-it-all. Let's start with chains. Think of a chain as a recipe for a really complex task. If you just tell the AI, hey, write me a quarterly compliance report, that's way too big of a job. A chain breaks it down into a step-by-step recipe. Step 1, go find the latest regulations. Step 2, look at our internal documents. Step 3, write a draft. Step 4, put it in the right format. It just gives the AI a clear, logical plan to follow. But a great plan doesn't mean much if you don't have the tools to get the job done, right? And that is exactly what tools are. They're like apps on a smartphone for the LLM. When a step in the chain says do the math, it can call a calculator tool. When it says get sales numbers, it can query a database tool. It can even call an API to book a flight for you. This is what gives the model actual superpowers, way beyond just spitting out words. So when you put it all together, the data, the chains, and the tools, what you get is a complete transformation. You're no longer dealing with a simple text generator. You've built an active, adaptive, honest-to-goodness problem solver. There's this quote from the source material that just nails it. The whole point is to turn these LLMs into adaptive, context-aware agents. In plain English, that means creating an AI that doesn't just repeat things it's learned, but one that can actually understand the situation you're in and use the resources it has to figure out a real solution. And this is where it gets really exciting, because it's not just theory anymore. Just think about what this makes possible. A doctor could ask a medical question and get an answer that includes research that was literally published this morning. A bank could analyze transaction data from right this second to spot fraud before it happens. I mean, these aren't just small upgrades. These are things that were totally impossible for a standard disconnected AI. We're talking about solving real, urgent problems right now. So that really leaves us with one big, important question to chew on. We're standing at the edge of a new era where AI doesn't just talk about the world, it actually interacts with it. It can go find information, it can crunch numbers, it can kick off processes in other systems. And that means the most important question we need to ask about the future of AI isn't, what is it going to say to us? It's, what is it going to do?